Alright, so today we are dealing with histograms. So generally with your histogram, you don't have to usually make one. They give you the picture of it and you have to be able to answer questions off of it. So our first kind is a frequency histogram, which is a way to display data similar to a bar graph. And the bars have to be touching one another. You cannot have spaces in between those. Otherwise, it is no longer a histogram. It is now just a bar graph. So they have to be touching. So a frequency means how many times something occurs. So if you had to draw a frequency histogram, you would complete the table, draw your horizontal axis, all this good stuff, and you'd follow these lines here. But this is what a frequency histogram ends up looking like. So we've got our x-axis down here. You've got your y-axis right there. Those always have to make sure that those are drawn in. Does anybody know what we call this little heartbeat looking like thing? That's a break. This is a break in the graph. Because what ends up happening is you need to have a consistent scale. Now, we aren't just going to go from 0 to 41 with our data, so we have to put a break in the graph. That's showing we're skipping some numbers, and now we're going to 41 to 50. So if you need that, you need to have a break in the graph. You can sometimes have a break going up vertically, but not as common generally. Your break is in your horizontal axis. So let's take a look at this. How many test papers did the teacher mark? So we're looking for how many total. So we have to look at each bar and figure out how many are in that section. So this first one, if we look over here, that's partially between 2 and 4. So that means there's how many papers here? So 3 people got between a 41 and a 50. How many in 61 to 70? And 71 to 80? 11. 81 to 90? 8. That goes right up to the line. And then 91 to 100? How come there's no bar here at 51 to 60? Because nobody got in that score, so there's no bar there. It's not that they didn't put it there, it's just that represents 0. So to figure out how many test papers she graded, we got to add them all up. What? Oh, I thought you said 34. So she graded 32 papers. So they want to know which interval contains the median score. So who remembers what the median actually is? Yes, median means our middle number. Now, since we don't actually know what the numbers themselves are, it's difficult to find your middle number. So the way we do it with our histograms is I'm going to take my 32 total scores, divide it in half, and what do I get? 16. So that means I'm looking for my 16th test score. That's going to be my median. That's going to be my middle. So here are my first 3 test scores. And then this would be numbers 4, 5, 6, and 7. So between here, I've got 7 total so far. So then here I'd have 8, 9, 10, 11, 12, 13, 14, 15, 16. So my 16th number is going to fall in that column right there. So the interval that contains our median is 71 to 80. Now, it just also so happens that 71 to 80 would be our mode, but it does not always work out that way. So see within which range did most students score? In which range did most students score? (71 to 80). That had 11 test papers in there, so that's where most people scored. And what percentage of students scored more than 70? Well, let's figure out how many students total scored more than 70. So we had 11 who scored between 71 and 80. That would be more than 70. Plus the 8 of them that got in the 80s, 81 to 90. Plus the 6 that got 90s, 91 to 100. So how many total got a score of 70 or higher than 70? What was that? 25. So to figure out our percentage, 25 over 32 gives us what? Should be a decimal. 2, what is it? 125. So to turn that into a percent, you just have to move your decimal 2 places to the right. So it's 78.125% of them. Do not round your decimal if they don't tell you to. You got to keep the whole thing. So our next kind of histogram, though, is our cumulative frequency histogram. Now this is different because a cumulative frequency histogram starts with the lowest interval and adds the previous total to it. So what ends up happening is, for example, you've heard the word cumulative before. Like they talk a lot in the winter about our cumulative snowfall. What does it mean to be the cumulative snowfall? All together. It's the whole thing throughout the season. They start at the beginning of the season and they keep adding how much snow we get until we get to the end of the season. Right now they're figuring out our cumulative rainfall because we got a lot of rain coming right now, so it's causing a whole bunch of flooding, but so they're keeping track of how much rain we're getting. So that word cumulative just means since the beginning, and they keep adding it up. So what happens is with your cumulative frequency table, is it ends up looking like this, which to me kind of looks like steps. So if you get a histogram where it looks like a whole bunch of steps, that is a cumulative frequency one. So that means they keep adding it up. Your other hint that it is a cumulative frequency is if you look at your intervals down here, your intervals all start with the same number. They all start with a 50. So that tells you it's adding 50 to 99, and then it's 50 to 149. So they added more to it, and then to 199. So with our cumulative frequency histograms, the easiest thing to do is to create a table where you're breaking them apart, so it's not cumulative anymore. So let's create a table. So with our table, your first interval is still going to be that same first interval that's on your graph. So 50 to 99. So how many did we have in this first bar here? 7. So now for the next one, we're not going to use 50 to 149. We're going to break them apart. So you're going to take your 99. To start your next interval, you're going to add 1 to it. So this would be 100 to 149. So what I've done basically is I've taken this interval of 50 to 149 and I've subtracted out from it the 50 to 99 that I've already figured out. So now to figure out how many people swam 100 to 149 yards, we would first figure out this bar is how tall. It goes to 12. I have to subtract the 7 from the one before it. So that means there were 5 new people added in there. So that means 5 people swam 100 to 149. So then our next interval, again, add 1, would be 150 to 199. Is that bar any taller than the one before it? No, so that means nobody swam just 150 to 199 yards. What would my next interval be? 2. Very good. So again, this bar goes up to 15, but I have to subtract the 12 from before it. So that means we got 3 new people there. And so then our last one would be what? Very good. That bar goes up to 20. And then you subtract the 15 from before it. So we get 5. So also, since this is a cumulative frequency table, this last bar, however tall it is, that is your total. If we were to add these numbers up after we've separated them, we still get the same total of 20. So there's 2 ways we can find our totals with our cumulative frequencies. So once you break apart your cumulative frequency and you make your table, it then makes the questions you have to answer a lot easier. So they want to know, based on the cumulative frequency histogram, determine the number of swimmers who swam between 200 and 249 yards. Well, we have that right here. That was 3 people. Do you guys even know how long 200 to 249 yards is? But in a pool. How many laps is that? Well, down and back is considered 1 lap, and that's 50 yards. So to go 200 yards, you have to go down and back 4 times. And then 250, you have to go down and back 5 times. So, has anybody ever done that before? Yeah. It's not easy. I used to be a competitive swimmer, so I did it all the time. But in order to be a lifeguard, you have to be able to swim a 500-yard swim non-stop in a certain amount of time.
How many yards?
500. So that means it's down and back 10 times without stopping. Not an easy feat to do. So this one person I know who recently was going to get his lifeguarding, there was like 30 people in the class, and so the first thing they did was this 500 swim. After about 5 minutes, they lost 10 people already because they couldn't do the swim. And then at the end of the class, there was only 5 of them left because they all got kicked out because of the swim. So that's not easy. Being able to swim 200, 249 yards, that is a big deal. Then again, also to be a lifeguard, you have to be able to tread water with your arms out of the water. You don't get to use them. With just your legs. And then you have to be able to tread water holding the diving brick, which is like 10 pounds above your head. Not easy. Well, think about it. If you're lifeguarding, you have to be able to drag people out of the water. So you have to be able to do a lot of stuff with just your legs or just your arms. All right, let's go on. Part B. How many swimmers swam between 150 to 199 yards? 0. C. Determine the number of swimmers who took the test. 20. How many swimmers swam more than 199 yards? So yep, that would be the 3 who swam 200 to 249 plus the 5 who swam 250 to 299. So that would be 8 total. And in what 10-yard frequency interval of distances did most people swim? Well, that's a typo. That should be 50. In what 50-yard frequency interval did most people swim? So if we look at the table, which interval had the most people? 50 to 99. Well, 50 is just down and back. And then 99, round it to 100, be down and back twice. All right. Moving on to another kind of graph that we use in statistics, which is our scatter plot. We're going to deal just a little bit with scatter plots today. We're going to do more with it next class. So a scatter plot is a graphical display of statistical data plotted as points on a coordinate plane to show a correlation between two quantities. Points are not connected. That's why it's called a scatter plot. You have points scattered all across the graph that you're not connecting. You're not trying to connect the dots and make a pretty little picture here. It's meant to be random. So then what happens with our scatter plot is a lot of times we try to find the middle of the data. So in order to do that, you would sit here and you would draw a line kind of going through the middle. Does anybody remember what we call that line? It's got two names. No. Line of best fit is one word we have for it. Again, it just means you're going through the middle of your data. You're basically trying to find the average of your points. The other word that they like to use for it is also a trend line. Kind of summarizing the data, finding the middle of it, that's you finding the trend amongst the pieces of information that you have here. So what we're going to deal with first is a correlation versus a causation. So a correlation means that things are either connected or not connected. Like, for example, it being a warm, hot, sunny day and the amount of ice cream that Skippy can sell. There's generally a correlation between those. Generally on the hot, warm, sunny days, Skippy sells more ice cream out of the ice cream truck. However, for causation, which people mess up that word a lot. They like to use the word within the problem of causal, which people will look at that word and they think it says casual, but it's really not. It's causal because the U and the S are switched. Causal means a reason for why the data relates or doesn't relate to the study. So causal, you just have to think to yourself, does one cause the other one to happen? So going back to my ice cream example, the fact that it's a warm, hot, sunny day, does that actually cause people to buy ice cream? No. Being a hot, warm, sunny day does not physically cause a person to reach into their pocket, get their money, and buy ice cream. It's correlated. They generally happen together, but there is no causation there. Another good one that they like to ask is a rooster crowing and the sun rising in the morning. Again, there's a strong correlation there. They do generally happen at the same time, unless you happen to have like a blind rooster or something and you can't tell when the sun's rising. But
That's so sad.
you hear roosters crowing like at midnight because they, yeah. But it's not causal. The rooster crowing does not cause the sun to rise in the morning. They're just correlated. They happen at the same time usually. So that's what this little paragraph here means. Correlation does not necessarily mean causation. Just because there's a strong correlation between two data points does not mean that one forces the other one to happen. So for correlation, it tells us how related two things are. There can be a strong correlation or there can be a weak correlation between them. The way we determine that is with what we refer to as the correlation coefficient, and we use the letter R to represent that. For today, we're not going to be calculating our correlation coefficient. We're going to actually do that next time. Today, we're just going to see the differences between it. So your correlation coefficient shows you the strength and the direction of the variables, because your correlation coefficient can be positive or it can be negative. And it's always between -1 and +1. So any of those decimals in between there, including 0, can be a correlation coefficient. So the way we figure out our correlation coefficient is using your trend line or your line of best fit. So like for example, this one here is a negative correlation because you have a negative sloping line. This one over here would be a positive correlation because your line of best fit is a positive sloping line. So your slope of your line also helps you determine your correlation. So if we take a look at our examples on the bottom, they want us to describe the correlation, whether it's positive, negative, or no correlation. And then we're just going to estimate the value of your correlation coefficient based off the points. So the way we do that, first thing we want to do is try to draw a trend line right through the middle of your data. So let's have you do that for the first one. If your trend line, you want to try to hit a couple of points, and then you want some points above and some points below. So this one, since our trend line is a positive sloping line, that means this has a positive correlation. Now all of my points here are pretty close to my trend line. Got a couple on them, but they're all pretty tight in there. So for a correlation coefficient, I would say this is approximately 0.85. It's a value close to 1. A correlation of 1, the points would line up exactly like that. So this would be a correlation of 1. Because if I draw my trend line, it's going to hit every single point. So the fact that this one's spread out a little bit more, it's not quite 1. It's definitely not 0.5 though, because they would be even further apart. So number 2, let's draw our trend line again. You want to go through the middle, hit a point or two. Other ones are going to be around it. So my line's approximately there. So is this going to be positive, negative, or no correlation? Negative. Now the points on that graph, they're a little further apart from my trend line than these points were. Does everybody see that? How they're a little further apart than this one? So I would say it's still pretty close to 1, but not as close as the last one. So I'll say it's approximately negative 0.75. Now for number 3, can we see where there's going to be a trend line at all? No. So this one has no correlation. So your R would be a 0. So the closer you are to 1, the stronger your correlation is. The closer you are to 0, the weaker your correlation is going to be. So we got 3 questions on here on the back. So which of the following statements shows a relationship that is correlated but not causal? So we're looking for correlated, not causal. The number of hours worked and how much money is made. Well, those are definitely correlated, and let's think about it. Is it causal? Is me working more hours give me more money? Yeah. And then me working less hours, does that give me less money? Yeah, so that one is causal, so that's not the one we're looking for. We're looking for one that's not causal. The amount of rainfall received and the level of water in the lake. Well, if we get more rainfall, what happens to our water level? Goes up. What if we get like no rainfall? It goes down. So is that causal? Yeah, that's going to be a causal. The increase of warm sunny days and the number of ice cream vendors visible. No, it's correlated. They do generally happen together. But the warm sunny day does not cause the ice cream vendors to go outside. So 2, which of the following shows a causal relationship and not just correlated? So this time we are looking for the one that's caused by the other one. A child's weight increases, so does her vocabulary. Does anybody's weight affect how much they know? No. A decrease in temperature and the increase in attendance at an ice skating rink. No, I mean, they're correlated. A lot of people do generally go ice skating in the winter, but it doesn't cause them to go. An individual's decision to work in construction and his diagnosis of skin cancer. No, I mean, it's related, because if they're working in construction, like I'm always yelling at my husband right now because he doesn't put sunscreen on. So what happens if you don't put sunscreen on? You get burned a lot. You get burned so many times. What do you get? Skin cancer. So there is definitely a correlation there, but it's not a causation. So then the number of minutes spent exercising and the amount of calories burned. Yes, the more minutes you exercise, the more calories you burn. The fewer minutes you exercise, the fewer calories you burn. All right, now last one. Which statement below might be caused by the statement, the more the furnace runs, blah? Is it the longer you'll have to let your car warm up? No, furnace doesn't cause you to have to warm up your car. The warmer the house becomes? Does your furnace running cause your house to get warmer? Yes. That's it right there.